For most of human history, when we looked into the darkest parts of the sky, we imagined emptiness. We imagined distance so severe that nothing could survive there, nothing could shine there, nothing could wait there. And yet, just a short while ago, the James Webb Space Telescope looked into one of those supposedly empty regions again, and what came back was not silence. It was not a lonely patch of black. It was a flood of hidden light, ancient light, crowded light, the kind of light that makes even familiar ideas about the universe suddenly feel unfinished. This is why people say James Webb just stopped the world. Not because the telescope found a monster racing toward Earth, and not because it exposed some cinematic disaster, but because it did something far more unsettling and far more powerful. It showed us that even in a place we thought we had already studied deeply, carefully, almost completely, reality was still holding back thousands of secrets. There is a tiny patch of sky that from Earth looks like almost nothing at all. No bright star claims it. No glowing nebula advertises it. No obvious galaxy marks it out for the naked eye. For a casual observer, it is just darkness. Years ago, Hubble stared into that darkness and changed astronomy forever. It revealed that the blackness was never empty. It was packed with galaxies, each one carrying billions of stars and vast histories of birth, collision, dust, and fire. That image became one of the most humbling pictures humanity had ever seen because it destroyed a very old illusion. It proved that emptiness is often just a limit of vision. But now James Webb has gone back to that same legendary region, and what it saw makes even Hubble's astonishing view feel like the opening chapter instead of the whole story. Webb did not erase Hubble, it did something more dramatic. It completed Hubble's sentence and then kept writing. After nearly 100 hours of observation focused on that same region, Webb pulled up galaxies Hubble could not clearly reveal. It found faint objects emerging from what once looked like blank background. It exposed red galaxies buried so deeply in infrared light that older instruments could only hint at them. It turned vague smudges into systems with structure. It filled dark pockets with new sources. And when astronomers compared the Webb image to the older Hubble view, the effect was immediate. Areas that had once appeared sparse suddenly looked populated. Regions that seemed finished suddenly looked incomplete. That is the emotional jolt of this discovery. The world did not stop because the sky changed in a violent instant. The world stopped because our confidence did. The same sky was there all along. The same ancient light was already traveling. The same hidden galaxies were already waiting. What changed was the eye we use to look, and that difference is big enough to reorder how you feel about the cosmos. To understand why this matters so much, you have to understand just how absurdly small this patch of sky really is. If you held a grain of sand at arm's length, the amount of sky covered by that tiny speck would feel comparable to the sort of area deep field astronomy targets. In other words, Webb was not surveying some giant swath of heaven. It was drilling deeper into a microscopic pinhole in the darkness. And inside that almost laughably small patch, the universe kept unfolding. This is the part that shakes people. If one little patch of black can contain so much history, so much structure, so many galaxies layered through time, then the larger cosmos is not merely vast, it is saturated, it is overflowing, it is denser with story than our instincts allow us to believe. We are not living in a mostly empty universe with a few islands of matter scattered here and there. We are living inside a cosmos where hidden structure waits in every direction for someone patient enough and powerful enough to look. Hubble had already taken us stunningly far. It gave humanity one of the greatest visual revelations in scientific history. But Hubble had limits, and those limits were not failures. They were simply boundaries set by wavelength, sensitivity, and time. Some of the oldest galaxies in the universe are not easy to see in visible light because the expansion of space stretches their light into longer wavelengths. Other galaxies are wrapped in dust so thick that their brightest activity hides behind a veil. Some are simply too faint to rise clearly above the darkness in shorter observations. Hubble could show us visible and near-infrared beauty with extraordinary clarity, but there were still objects too red, too dusty, too ancient, or too dim for it to fully expose. So the old deep fields, for all their power, still carried an unanswered question inside them. What was still hiding there? What had we not yet earned the right to see? That question sat quietly for years. Then Webb arrived with a completely different kind of vision. James Webb was built for this kind of work. Its mirror is far larger than Hubble's, which means it can collect far more light. Its infrared instruments allow it to detect light that has been stretched by cosmic expansion and light that can pass through dust, which once concealed entire regions of activity. Where visible light astronomy can run into walls, infrared can sometimes slip through them. That is why Webb feels almost supernatural in deep field work. It does not magically invent galaxies that were not there. It reveals wavelengths Hubble was never optimized to capture at the same depth. It sees farther into the red, deeper into buried structure, and longer into the universe's own memory. In these observations, Webb used instruments designed to gather both near-infrared and mid-infrared data, giving astronomers a richer and more layered view of what this patch of sky truly contains. The result is not just prettier data. It is more honest data, more revealing data, data that makes the darkness answer back. One of the most striking results from Webb's return to this field is that it revealed at least 2,000 additional objects that Hubble had not clearly shown. Let that settle for a moment. This was not some brand new, untouched region no telescope had ever studied. This was one of the most famous and most carefully observed patches of sky in the history of astronomy. And still, after all that attention, after all those years of belief that we had already seen its great secret, Webb found thousands more sources. That is why this feels like more than a normal update. It is a reminder that even our most iconic discoveries can remain incomplete for decades. It is a reminder that the universe often yields truth in layers. First, it gives us the headline. Then, much later, if we build a better eye and ask a better question, it gives us the scale of what we missed. Webb did not just add detail. It changed the meaning of the darkness by proving it still held abundance beyond our last limit. And the new objects Webb pulled forward are not all the same kind of thing. Many of the most scientifically valuable sources are the reddest ones, because redness in a deep field can mean several extraordinary possibilities. It can mean the object is extremely distant, its light stretched by the expansion of the universe over billions of years. It can mean heavy dust is obscuring vigorous star formation inside. It can mean a mature stellar population formed surprisingly early. It can even point toward active galactic nuclei, where supermassive black holes influence the core of a galaxy. In other words, these are not just extra dots added to an image for cosmetic drama. Each faint red source is a clue. Each one may represent a missing stage in the story of how galaxies assembled, how stars formed, how dust spread, how black holes grew, and how the early cosmos transitioned into the structured universe we inhabit now. In deep field astronomy, even a smudge can carry the weight of a chapter. That is why this image becomes more than beautiful. Beauty is only the first layer. What Webb really gives us here is a cross-section of time. When we stare into a deep field, we are not seeing one moment frozen in space. We are seeing a timeline stacked into a single frame. Nearby systems show us a relatively later universe. More distant ones show us earlier cosmic eras. The faintest, reddest, hardest-to-reach objects may belong to epochs when the universe was still young, when structure was still assembling, when the first major chapters of galaxy growth were still being written. So when Webb fills in darkness that Hubble once left open, it is not merely increasing the crowd in a photograph. It is increasing the number of historical witnesses available to science. More objects mean more checkpoints across time. More checkpoints mean better models. Better models mean a clearer understanding of how the universe moved from the first large structures to the galaxies, stars, and worlds that eventually made our own existence possible. This is also where the deeper philosophical shot begins to creep in. We like to imagine that as telescopes improve, the universe becomes simpler, clearer, and more settled. We tell ourselves that sharper images will close mysteries. But the opposite often happens. Better instruments do not shrink reality, they expand it. Every time our reach improves, the cosmos becomes more layered, more crowded, more ancient, and more difficult to finish describing. Webb's deep field result is a perfect example of that pattern. The telescope did not merely confirm what we already suspected, it widened the scale of the unknown. It told us that one of our most famous cosmic windows was still incomplete. It told us that apparent emptiness remained unfinished under longer observation and better infrared reach. It told us that what we call darkness is often just hidden abundance. And once that thought settles in, the discovery becomes impossible to shrink back down into a normal science headline. It starts to feel personal. It starts to feel like the universe is larger not just in size, but in honesty. Think about what redshift really means in this story. The farther away a galaxy is, the longer its light has been traveling to reach us. During that journey, the expansion of the universe stretches the light toward the red and infrared part of the spectrum. So when Webb sees deeper into infrared light, it is not just seeing dim color, it is seeing older chapters of cosmic history carried in altered wavelengths. Some of the galaxies Webb picks out in this field are interesting precisely because Hubble could not fully capture them in the same way. Their light had been shifted too far, or buried behind too much dust, or diluted into faintness that needed more time and more collecting power. Webb reaches for those reluctant signals and translates them into something science can actually use. That is why these new sources matter so much. They are not generic additions to a cosmic crowd. They are witnesses from farther back in time, or from more hidden environments, or from both at once. That matters because galaxies are not born fully grown. They emerge through long, violent, beautiful processes involving gravity, gas, dark matter, dust, mergers, star formation, feedback, and black hole growth. If you want to understand how the modern universe came to look the way it does, you have to catch galaxies at many different stages of that long evolution. Some deep field objects show youth, others show maturity, others show obscuration, others may show intense star formation or central activity that changes the future of the whole system. When Webb adds thousands of sources to a region we thought we knew, it gives astronomers more checkpoints in that evolutionary story. Suddenly, a picture that once looked complete becomes a richer archive. Questions about when certain galaxies formed, how quickly dust built up, how soon mature structures appeared, and where hidden star formation was taking place all become easier to ask with precision. This is why a single, deeper image can ripple far beyond aesthetics. One frame can quietly alter the scaffolding of cosmic history. And then there is the emotional side of the comparison, the part people feel even before they fully understand the science. Hubble's deep field already told humanity something unforgettable. It told us that what looks empty is not empty. Webb returns to that same place and tells us something even more unsettling. It tells us that what looked full was still missing thousands of things. That is an extraordinary progression. First, we learn that emptiness is an illusion. Then we learn that even our correction of that illusion was incomplete. This is why the phrase, "James Webb just stopped the world," resonates so strongly. A discovery like this forces a pause. It makes people stop scrolling, stop talking, stop treating the cosmos like background decoration. Because for one moment, the sky stops being familiar. The stars and galaxies feel less like a finished atlas and more like an unfinished confession. The telescope did not invent wonder, it deepened it. And in doing so, it reminded us that scientific progress is not always the reduction of mystery. Sometimes it is the disciplined expansion of it. It is also important to understand that Webb and Hubble are not enemies in this story. Webb is not humiliating Hubble. It is continuing the conversation Hubble began. Hubble asked the first profound question by staring into a blank patch of sky and revealing that the darkness contained thousands of galaxies. Webb comes along and asks a harder question. If that darkness already hid so much, what else was still concealed in the wavelengths Hubble could not fully chase? The answer is now written across this deep field return. More objects, more red systems, more hidden structure, more evidence that a familiar region was still holding back ancient light. That is how science usually advances at its best. One instrument opens a door, another walks farther through it. One generation names the mystery, the next generation gives it depth. Webb does not diminish what came before. It turns an iconic result into a multi-generational discovery, a layered truth built by patience, engineering, and the willingness to keep looking at something others might have assumed was already finished. This comparison also teaches something subtle about what telescope images really are. People often imagine a deep image as simply a better photograph, as though space were sitting there unchanged and our instruments merely took prettier snapshots of it over time. But every deep field image is also a construction of physics, time, optics, and translation. Human eyes cannot see infrared light, so Webb's data has to be mapped into visible colors that help scientists interpret it. Bright sources show diffraction patterns shaped by the telescope's design. Resolution depends not only on mirror size, but also on wavelength. A larger mirror helps, but longer wavelengths behave differently than visible light. All of this means Webb's image is not just sharper in some simplistic sense. It is sensitive to different information. It is capable of telling a different truth about the same patch of sky. That is why this result is so rich. It does not just say the old image was blurry. It says reality has layers, and each layer becomes visible only when the right instrument, the right wavelength, the right exposure time, and the right patience come together. Now imagine how unsettling that becomes when you pull back from the image and think about the whole universe. If this tiny patch of sky, already famous, already celebrated, already studied for years, still contained at least 2,000 additional objects Webb could bring out, then what does that imply about all the other regions we have not stared at as deeply, or not yet revisited with the same power? How many more galaxies are waiting in patches we casually call dark? How many dusty systems remain hidden? How many early structures are still sitting beneath our thresholds? How many populations have gone undercounted because the universe speaks in wavelengths we only recently learned to hear well? This is where the discovery expands from one beautiful image into a much larger challenge to our intuition. It reminds us that census-taking in the cosmos is never final. Each improvement in sensitivity can change not just a number, but a worldview. The universe keeps exceeding the category of enough. There is another reason this moment feels so powerful. Ancient light is emotionally different from ordinary information. When Webb pulls a hidden source out of darkness, it is not discovering a thing that began existing the moment the data appeared on a screen. It is receiving a message that has been traveling for billions of years. Some of that light began its journey long before Earth looked anything like it does now, long before humans existed, long before our species imagined glass, lenses, rockets, mirrors, spectrographs, or pixels. The light was already coming. It crossed the expanding universe for incomprehensible spans of time, waited out the rise and fall of countless stars, drifted past galaxies and voids, and only now ended its journey in a machine built by one brief civilization on one small world. That thought alone is enough to stop people in their tracks. It means every hidden source in Webb's deep field is not just an object. It is a delayed arrival. It is history finally reaching a witness capable of understanding it. And if that were the whole story, it would already be enough. But Webb's deep field does something more. It sharpens the future as well as the past. Once astronomers know that one iconic region still contained a deeper population of galaxies, the next question becomes unavoidable. How much more lies beyond Webb's current reach? This is the re-hook inside the discovery, the part that keeps the mind from closing. If Hubble showed us that the darkness was crowded, and Webb showed us that the crowd was even larger than Hubble realized, then Webb itself may eventually become another beginning rather than an ending. Future instruments may revisit the same field and expose still fainter objects, still redder objects, still stranger systems hovering at the limits of today's confidence. That is the real pattern hidden inside every great astronomical image. No deep field is final. It is a temporary agreement between the universe and the best eye we currently possess. Improve the eye, and the agreement changes. And this is the point where the story starts to feel almost spiritual without ever leaving science. Not mystical, not magical, not vague, but spiritual in the sense that it reorganizes scale and humility. Webb's deep field reminds us that the universe is not obliged to look simple just because we have finally built a better mirror. It reminds us that our greatest breakthroughs are often corrections of our own overconfidence. For a long time, the Hubble deep images felt like the cleanest answer we could imagine to the question of what hides in darkness. Webb has now shown that those answers, while revolutionary, still sat inside a larger hidden world. It is hard not to feel something when you realize that the most famous emptiness in astronomy was still crowded beyond what we knew. It makes the cosmos feel patient. It makes human knowledge feel brave but temporary. It makes every discovery feel like both a victory and a confession. We are better at seeing now than we were before, and that improvement has not simplified the sky. It has made the sky richer. So what exactly did James Webb see when it returned to this legendary field? It saw that the darkness was still not empty. It saw that even after one of the most celebrated observational triumphs in human history, there were still thousands of hidden objects waiting for a deeper eye. It saw galaxies Hubble could not clearly bring out. It saw redder, dustier, fainter, and older populations that help fill out the story of cosmic growth. It saw a region we thought was complete and made it incomplete again in the best possible way. That is why the discovery lands so hard. It reaches beyond astronomy and touches something psychological. Human beings want closure. We want to believe that when we finally solve a mystery as big as the deep field, the chapter ends. Webb arrives and calmly refuses that comfort. It says the chapter did not end. You had only read as far as your instrument could read. And maybe that is the real reason the phrase "stop the world" feels earned here. Not because everyone on Earth literally froze in place, but because a discovery like this compels mental stillness. It creates one of those rare moments when the scale of reality overwhelms the speed of modern life. For a few seconds, the endless noise of the day becomes smaller than one fact. The universe hid more in that darkness than we knew, and the hidden light was there the whole time. That thought can cut through anything. It can cut through cynicism because the result is too elegant to dismiss. It can cut through distraction because it connects engineering, patience, history, and wonder in one image. It can cut through arrogance because it proves that even our most iconic victories over ignorance can remain partial. And it can cut through fear because the discovery, at its core, is not about catastrophe. It is about revelation. It is about the sky becoming fuller the longer we refuse to look away. If you want to feel the scale of this properly, picture the timeline embedded in the frame. Some of these newly visible galaxies may represent systems from astonishingly early eras of cosmic history. Others may be wrapped in dust that once hid star formation from our view. Others may hold mature stars or active centers that help astronomers map out how matter organized itself over billions of years. Together, they tell us that a single image can serve as an archive of transitions: gas becoming structure, structure becoming galaxies, galaxies growing through mergers, dust obscuring and then revealing, ancient light arriving from distances so vast that ordinary language almost gives up trying to contain them. That is what makes a deep field one of the most powerful ideas in science. It is not just a picture outward, it is a history downward. It lets us excavate reality through light. And Webb has just dug deeper into one of the most important cosmic excavation sites humanity has ever chosen. That excavation has consequences for the future of astronomy as well. Every time a field like this yields more than expected, it sharpens the case for going deeper still, for revisiting old targets, for designing instruments that can push beyond current thresholds, and for treating no iconic image as final. Today, Webb shows us at least 2,000 additional objects in a region long associated with Hubble's triumph. Tomorrow, an even more advanced observatory may return to the same patch and reveal sources too faint even for Webb, or separate blended structures, or refine distance estimates, or trace hidden processes with spectroscopy in ways today's data can only suggest. That is how the frontier moves, not with one final photograph, but with repeated acts of looking. The night sky does not surrender its truths all at once. It yields them by wavelength, by mirror size, by exposure time, by patient generations willing to inherit an old question and ask it with sharper tools. So when people say James Webb just stopped the world, hear the deeper meaning beneath the drama. Hear that a telescope went back to one of the most famous patches of darkness ever studied and found that the darkness still had more to say. Hear that the universe remains denser with hidden history than our previous best images could prove. Hear that Hubble's lesson was not overturned, but enlarged. Hear that science, far from exhausting wonder, has once again widened it. Hear that a grain-sized patch of sky can still humble a planet full of equations, observatories, archives, and certainty. And hear the implication that follows all of it like an aftershock. If this much was still waiting in one place we thought we knew, then the rest of the cosmos may be carrying entire libraries of unseen light, and we have only just begun to open the shelves. Because in the end, that is what Webb really revealed. Not merely more galaxies, though it did reveal those. Not merely a stronger image, though it gave us that too. What it revealed was the failure of emptiness as a concept. It showed us that darkness is often unfinished visibility. It showed us that reality exceeds the eye that measures it. It showed us that every improvement in our instruments can become an improvement in our humility. And it showed us once again that the universe is not done surprising the species that dares to look back at it. So the next time you hear someone say James Webb stopped the world, remember why. It was not because the universe suddenly became stranger than fiction. It was because the universe became more honest than our last picture of it. And for one unforgettable moment, humanity had to stand still long enough to absorb the difference. If this discovery rewired the way you think about the night sky, then stay with that feeling for a second before you let it pass. Let it remind you that some of the greatest scientific moments do not arrive as explosions. They arrive as deeper versions of familiar truths. They arrive when an old darkness fills in. They arrive when a legendary image turns out not to be finished after all. And they arrive when a machine built by human hands, floating far beyond Earth, collects ancient photons that began their journey billions of years ago and finally tells us, with devastating calm, that there was always more there than we imagined. So now the only honest question is the one Webb leaves behind for all of us. If there were still thousands of hidden galaxies waiting in one of the most studied windows in the sky, then how much more of the universe is still out there, waiting for the next deeper eye? Let me know what you think in the comments, and if you want more cosmic stories told with wonder, clarity, and the full weight of what the data really means, stay close, because the universe is not finished speaking yet.